Hello everyone, thank you very much for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Tot. Dr. Tot, do you want a cookie? Yes. Start class and welcome to SAT, ACT Prep. Today and this week in general, we're going to take a step back and do a practicum exercise with some miscellaneous drill sets. So we're going to look at multiple clusters of pairs of SAT questions in 3 alternates. So we're going to have a total of 3 pairs that I'll give you 6 minutes each. So you have 3 different opportunities to attempt the 2 subtopics that are involved in each cluster. We'll go through as many sets as we can, and that'll be the basis of today's, Wednesday's, and Friday's session. Let me go ahead and share my screen with you. And as always, thank you for everyone, all the new subscribers out there. I appreciate you very much. If you find these videos helpful, then please like and subscribe and share with your friends. And just a reminder that these are live sessions, so there's a little bit of a delay with the iPad, but I'll try and mitigate that as much as possible by watching the broadcast stream. If you have any questions at any point, please let me know either by dropping a comment in the live section question feed or by dropping a comment below in the comment section. So let's look at the first question. I'm going to give you 3 minutes each. Again, these are just miscellaneous questions. So they're going to be testing various subtopics, most of which we haven't gotten to yet in the standard curriculum, but we will. You have many different examples of each of these problems as we go forward. But I'm going to give you 3 minutes per question, and I'll keep track of the time in the upper right-hand corner. After 2 minutes, I'll start to solve, so you can watch the screen if you need any hints. And I do apologize. I haven't started the timer yet. Let me read the questions for you. What are the solutions of the number 1 is, what are the solutions of the quadratic equation 6d squared minus 7d minus 3 is equal to 0? And number 2 is, how many gallons of a 10% iodine solution should be added to 50 gallons of a 5% iodine solution so that the resulting solution has an 8% iodine concentration? So I'll give you 6 minutes and I'll update the time per minute. Okay, so I started to solve about halfway through for both of them, but let me just explain the two different approaches that I have. So number one, we can go through solving for the solutions of this quadratic two different ways. Either one, we can factor, recognizing that this is a quadratic where a is not equal to 1, that leading coefficient is not equal to 1, so that means that we need to consider the factors of a times c that add together to get the b value, not just the factors of the c value that add together to get the b value. So that's what I'm considering here when I have a times c is equal to 6 times 3 is equal to 18, and you can see that I'm listing out the factors of 18, and I'm looking for two factors that would add or subtract together in a way to get the b value. The b value here is -7, so you can see that 2 and 9 would work together to do that. Then I look at my a values and see which factor of my a value, 6, will work with my factors of the c value. So notice that 2 and 3 are factors of 2 and 9. So that's why I'm going to pick 2 and 3 to work with, and that's why I place the 2 and the 3 I place the 2 and the 3 in the leading positions of those binomial square, because we're going to turn that quadratic, that overall trinomial, into a 2 binomial square. Now notice that the 2d and the 2 that I'm going to insert in, they're going to multiply with each other ultimately when I multiply outer times outer. So I need to reduce the factors of 18 by the factors of a that are the new leading coefficients. So that 9 I'm dividing by 3 because it's going to be multiplied by the 3d. That 2 I'm dividing by 2, I'm reducing by a factor of 2 because it's going to be multiplied by 2d when it's outer times outer. Now I just need to pick the operators here. I want it to be a -7. So that means I want a -9 and a +2 to add together for a -7. So this is going to simplify into 2d minus 3 times 3d plus 1. And this is all set equal to 0. So now we can use the principle of zero products and take each factor and set them individually equal to 0. When we do that, we're going to find that 2d is equal to 3. So d has to be equal to +3/2. And also on the other, in the other half of the equation, or the alternate form, we're going to find that 3d is equal to -1. So then d is equal to -1/3. So d is equal to +3/2 and -1/3, which is answer selection C. On the right-hand side, I use the quadratic formula. So we have -b plus or minus the square root of b squared minus 4ac quantity divided by 2a. That's something that you need to memorize. They're not going to give you that in the formula sheet on the SAT, and they aren't going to give it to you on the ACT. You want to make sure that you have that memorized. Substituting the values, and make sure that if the b value, like here, b is -7, if the b value of any one of those values is negative in the equation, make sure that you include that negative in when you substitute into the formula. So when we have -b, that's a -7, which is a +7, plus or minus the square root of -7 squared minus 4 times 6 times -3. So that's going to turn into 7 plus or minus the square root of 49 plus 72, quantity over 12. 49 plus 72 is 121. The square root of 121 is 11. So the answer here, notice, I'm going to continue this all the way on the left over here in green. So this turns into 7 plus or minus 11, quantity over 12. And if we split that into its two alternate forms, then that's either going to be 7 plus 11 over 12, or it's going to be 7 minus 11 over 12. 7 plus 11 over 12 is 18 over 12. 18 over 12 is +3/2. 7 minus 11 over 12 is going to be -4/2. 4 over 12, which is negative 1/3. So notice we get the same exact answers. We get positive 3/2 and negative 1/3, which is answer selection C. So you could have used either of those options. If you have any questions, then please just let me know. For number 2, it's almost similar to what we have going on here is kind of a weighted average problem. So if we're trying to figure out how many gallons of a 10% iodine solution should be added to 50 gallons of a 5% iodine solution so that the resulting solution has an 8% iodine concentration, what we're really talking about here is we want the amount of iodine divided by the total volume, or let me just be consistent, let me just say the general term amount. General amount of solution is equal to 8%. 8% written as a decimal is going to be 0.08. So 0.08, our intended solution, the solution concentration that we're looking for, is equal to some X number of gallons of a 10% solution. So X times 10%, or 0.1, 10% written as a decimal is 0.1, plus 50 gallons times a 5% concentration will give you the amount of gallons of iodine that are in the old solution at the 5% concentration. If you divide that by the X number of gallons that you're going to add, plus the 50 total gallons that you already have, that will give you a weighted average set equal to 8% that you can then solve for X with. So if First, I'm going to multiply on both sides by the quantity X plus 50 because I have that denominator on the right. So that's going to cancel the X plus 50s on the right, and that's going to leave me with, let me get a new color, that's going to leave me with X plus 50 times 0.08 is equal to 0.1x plus 50 times 0.05. And now I just need to distribute, or make sure that you distribute this 0.08, whoops, sorry. This 0.08 needs to go to both the x and to the 50, because in the first quantity it's separated by addition. So we're going to have 0.08x, 50 times 0.08 is going to be 4, so plus 4 is equal to 0.1x plus 0.05 times 50 is 2.5. Now I'm just solving for x. So I'm going to subtract away 0.08x on both sides. That will cancel on the left, and so I'll have 4 is equal to 0.02x plus 2.5. Subtracting 2.5 from both sides. That's going to leave me with 1.5 is equal to 0.02x. So x is equal to 1.5 divided by 0.02. So 1.5 divided by 0.02 is going to be 75. And that is answer selection C. If you have any questions, then please let me know. We're going to look at 2 other sets of these pairs, so we're going to get some more work with these. So I'm going to give you 6 minutes. I'd like you to look at numbers 3 and 4. Number 3 asks, what are the solutions of the quadratic equation 6f squared minus 6f minus 36 is equal to 0? And number 4 asks, how many gallons of a 20% iodine solution should be added to a 150-gallon, let me reread that. How many gallons of a 20% iodine solution should be added to 150 gallons of 5% iodine solution so that the resulting solution has a 12% iodine concentration? So I'll give you 6 minutes and I'll keep track of the time in the upper right-hand corner. the quadratic formula. So you could definitely go through and consider the factors of A times C, and it will work out. However, for time's sake and to be most efficient, here it might be a good judgment call just to switch right to the quadratic formula. So remember, that's negative b plus or minus the square root of b squared minus 4ac, quantity divided by 2a. So substituting in there, you're going to get negative 6 plus or minus the square root of negative 6 squared minus 4 times 6 times negative 36. Make sure that you include the negative sign when you substitute in that 36. It's really important because that turns the whole thing positive. Otherwise, you'd be taking the square root of a negative number, or that discriminant would be negative, and that means something totally different entirely. So you're not solving there. That means that the solutions would not be real values, and that would be very wrong in this case. So simplifying, that turns into 6 plus or minus the square root of 36 plus 864. 36 plus 864 is 900. So that's really 6 plus or minus the square root of 900, which is 6 plus or minus 30, quantity divided by 12. 6 plus 30 is 36. 36 divided by 12 is a positive 3. 6 minus 30 is a negative 24. Negative 24 divided by 12 is a negative 2. So our answer here is going to be a positive 3 and a negative 2, which is answer selection C. If you have any questions, then please let me know. Otherwise, for number 4, what we have going on here is a weighted average problem. So we're going to set the intended intended concentration rate of this solution equal to the 1 gallon amount times its concentration times the other gallon amount times its concentration, quantity divided by the total number of gallons. So we have 0.2 or 20% concentration times an unknown or X number of gallons that we're going to add, plus 150 gallons of a 5% concentration that we already have, quantity divided by X plus 150. The X here is the new number of gallons of the new solution that we're going to add in order to obtain a 12% overall concentration. I'm going to start to solve here by multiplying on both sides by X plus 150 in order to get rid of that denominator. So that eliminates on the right-hand side. And so to have 0.12 times X plus 150 is equal to 0.2 times X plus 150 times 0.5. Excuse me, 0.05. Make sure that you distribute this 0.12 to both values inside of that parentheses. So that's going to become 0.12x plus 150 times 0.12 is going to be 18, is equal to 0.2x plus 150 times 0.05 is going to be 7.5. I'm going to subtract 0.12x on both sides. That'll cancel on the left. And so 18 is going to be equal to 0.08x plus 7.5. Now I can subtract 7.5 on both sides. That'll cancel on the right. And so I'm going to have 10.5 is equal to 0.08x. And so x is going to be equal to 10.5 divided by 0.08. Which is going to be 131.25 gallons have to be added in order to obtain a 12% overall concentration. And so that's going to be answer selection A. If you have any questions at all, please let me know. Otherwise, let's take a look at the last pair of these two examples. So question number 5 asks, what are the solutions of the quadratic equation 8g squared minus 8g minus 6 is equal to 0? And number 6, which of the following is closest to the number of gallons of a 40% iodine solution that should be added to 250 gallons of a 5% iodine solution so that the resulting solution has a 16% iodine concentration? I'll give you 6 minutes. About 2 minutes in, I'll start to solve, and then we'll go through the answers. After this set, we'll go through, we'll change to 2 entirely different questions. Okay, so I just went ahead and substituted directly into the quadratic formula because I noticed that these A, B, and C values are quite large, especially the A value being 8. So that's going to give a pretty large A times C factor. So I'm just going to just go straight to the quadratic formula here. And that turns into 8 plus or minus the square root of 64 plus 192. Make sure to keep the negative signs of all the values of A, B, and C. Quantity divided by 16. So that's going to be 8 plus or minus the square root of 256. The square root of 256 is 16. So that's 8 plus or minus 16, quantity divided by 16. So that's going to be 8 plus 16 over 16, which is 24 over 16, which is divisible by 8. So that's going to be 3 halves. So we know that A and B are false because those are negative 3 halves. And then we're also going to have 8 minus 16, quantity divided by 16. So 8 minus 16 is a negative 8. Negative 8 over 16 is going to reduce down into negative 1/2. So our answer is going to be C. D is equal to negative 1/2 and 3 halves. I'm sorry, that's a typo. It should say G instead of D. So my apologies. It's a wrong variable there. But if you have any questions, then please let me know. Otherwise, for 6, we're going to set up the weighted average as such. So we want it to overall be 16% concentration. So 16% is equal to X gallons times 0.4%. So 40% concentration, which is 0.4 as a decimal, plus 250 gallons at a 5% concentration, which written as a decimal is 0.05. Quantity divided by X number of new gallons plus the 250 old gallons that we already have. Simplifying through, that's going to be 0.16 is equal to 0.4x plus 12.5. Just multiplying the 250 times the 0.05. Quantity divided by x plus 250. So I multiplied by x plus 250 on both sides, distributed through, and then I'm just solving for x. You end up getting x is equal to 114.583 bar. That just means the 3 continues forever. So the question asks which of the answer selections is closest to the number, and so that would be 115. That would be the closest value. If you have any questions, please let me know. Otherwise, let's look at a brand new pair of questions. So question number 7 asks, on a particular college campus, 40% of all students are male. If 20% of the students are athletes and 60% of all the student athletes are male, then which of the following is closest to the percent of female students who are not athletes? 8 asks, a wedding planner is ordering flowers for a client. The ratio of roses to lilies to orchids must be 3 to 4 to 5. If the order contains 600 flowers, what is the difference between the number of orchids and the number of roses being ordered? So I'll give you 6 minutes, and about 2 minutes in, I'll start to solve. Okay, so for number one, there's just a lot of information in this problem. So but they do present everything in terms of bimodal situations. So it's either this or that. There's no gray area between the categorizations at each level of delineation. So when they say that 40% of the students are male, that could also mean that 60% of the students are female, right? There has to be a balance there. So if 20% of the students are athletes, then 80% of the students are non-athletes. If 60% of the student athletes are male, that means that 40% of the student athletes are female. Then which of the following is closest to the percent of female students who are not athletes? So what we can do is break this information up into a tree diagram, starting with the entire student population. And they don't give me any values to work with the total student population, but I'm just going to assume a value because overall they're asking me for a percentage. So as long as I apply the correct algebraic processes, then I'm going to get the same answer no matter what value I start with. I just need to make sure that I do the right calculations. So if I consider that the entire student population is 1,000, then 20% are athletes, so there are 200 athletes. That means that there's 80% are non-athletes, meaning that there are 800 non-athletes. From each of those classifications, I'm going to split the groups into male versus female. So it says that 60% of the athletes are male. So 60% of 200 athletes is going to be 120 male athletes. From there, I know that there's 200 total athletes and 120 of them are male. So that means that 80 of them must be female, so that there's 80 female athletes. Of the 800 non-athletes, I know that there's a total, they say overall in this very first sentence, that 40% of all the students are male. So if 40% of all the students are male, that means that 40% of 1,000 or 400, there must be 400 males at this college. So then I can figure out how, from that total, if there's 400 total males and 120 of them are athletes, then 400 minus 120, or 280 of them, are non-athletes. Then I know that there's 800 total non-athletes. So 800 total non-athletes minus 280 male non-athletes would give me 520 female non-athletes. And so the question is actually asking me here, what percent of female students are not athletes? So that's going to be the 520 of the total 80 plus 520, or 600 female students. So notice the denominator here is not the total number of students at the university, it's the total number of female students. So this is going to be 520 over 80 plus 520. So that's going to be 520 divided by 600. And that's going to be 0.86 bar. And that's closest to 85%. Because they asked which of the following is closest to the percent of female students who are not athletes. So the answer here would be D. For 8, there's two ways of solving here. We can think of ratios as just comparisons of the numerators of fractions that have the same denominator. So for example, when they say that the ratio of roses to lilies to orchids is 3 to 4 to 5, if you sum those ratio elements together, that necessarily is the denominator of the fraction, and then you can use the ratio element as the numerator. So the number of roses that this person is ordering is going to be 3 over 3 plus 4 plus 5. In other words, it's going to be 3/12 of the 600 roses. The number of orchids are going to be 5 over 3 plus 4 plus 5, or 5/12 of the total 600. So you can, turn them into fractions. So this is going to be 3/12 times 600. 3/12 is, of course, 1/4. And so that's going to be 150 roses. 5/12 times 600 is 250. Now, they don't ask for either one of those numbers. They ask for the difference between the number of orchids and the number of roses. Difference implies subtraction. And so that's going to be 250 minus 150, which is a difference of 100. So that's answer selection A. The second way that you could have solved this problem is by representing each of the ratio elements in terms of x and then writing an equation. So for example, in the ratio of 3 to 4 to 5, we could say 3x plus 4x plus 5x must be equal to 600 total flowers being ordered. So that's going to turn into 12x is equal to 600. So the common multiple is going to be 600 divided by 12, which I believe is 50, but let me just check that. Yep. So the number of roses is 3x, so that's 3 times 50, which is 150. The number of orchids is 5x, so that's going to be 5 times 50, or in other words, 250. So notice we get the same answer. 250 minus 150 is 100. So you can solve ratio problems either by converting them into fractions, or if you're able to, you can represent each of the ratio elements in terms of x and figure out if there's a way of writing an equation with the information that's given. If you have any questions, please let me know. Otherwise, let's look at 2 other examples. Question number 9 asks, on a particular college campus, 30% of all students are male. If 30% of the students are athletes and 40% of all the student athletes are male, then which of the following is closest to the percent of male students who are not athletes? And number 10 asks, a wedding planner is ordering flowers for a client. The ratio of roses to lilies to orchids must be 5 to 7 to 9. If the order contains 840 flowers, what is the sum of the number of orchids and the number of roses being ordered? I'll give you 6 minutes, and after 2 minutes, I'll start to solve. Okay, so looking at question number 1, if we divide these into categories, starting with an assumed total number of 1,000 students, then if 30 of them are, excuse me, if 30% are athletes, that means there are 300 total athletes. They say that 40% of the athletes are male, so then 120 are male, and 180 or 60% would be female. 70% of the 1,000 students are not athletes, so that means that there's 700 non-athletes in this hypothetical situation. And they say that 30%, totally separate just in the first sentence of the question, 30% of all students are male. So I know 30% of 1,000 or 300 total males are at this university. So if I subtract 300, if I subtract 120 athletic males from the total 300 males, I'll get 180 non-athletic males. That has to add up to a total non-athletic of male and females of 700. So 700 minus 180 will give me 520 non-athletic females. The question's asking me then which of the following is closest to the percent of male students who are not athletes. So there's 180 non-athletic male students. There's 120 athletic male students. So we're going to take the number of athletic males divided by the total number of males. So it's going to be 180 over 300, which is 60%. And that's answer selection A. Question 10. We could solve this one of two ways. I use the fractional method here. So notice that if the ratio of roses to lilies to orchids is 5 to 7 to 9, then orchids represents 9 over 5 plus 7 plus 9 of the 840. So that's 9/21. So that's 9 over 21 times 840 is going to give me 360 orchids. 5 over 5 plus 7 plus 9 times 840 is going to give me 5 over 21 times 840, which is going to give me 200 roses. The sum implies addition, and I should have said which of the following is closest to the sum, so I apologize because it didn't turn out to be exactly. You had to estimate here or approximate, but I hope that you got or can recognize that 540 is going to be the closest value to 560. But I should have put which of the following is closest to the sum of the number of orchids and the number of roses being ordered. If you have any questions, then please let me know. Otherwise, these would be the last two problems that we attempt today. Let's look at 11 and 12. Question 11 asks, on a particular college campus, 48% of all students are male. If 42% of the students are athletes and 40% of all student athletes are male, then which of the following is closest to the percent of female students who are not athletes? And question 12 asks, a wedding planner is ordering flowers for a client. The ratio of roses to lilies to orchids must be 10 to 12 to 15. If the order contains 518 flowers, what is the difference between the number of orchids and the number of lilies being ordered? So I'll give you 6 minutes, and 2 minutes into those 6 minutes, I'll start to solve the problems. Okay, so looking at number 11, if we assume a total student population of 1,000 and they say that 42% of the students are athletes, that means that there's 42% of 1,000 or 420 athletes. That means that 58% of the population are not athletes, meaning that there's 580 non-athletic students. Of the 420 athletes, they say that 40% are male. So 40% of 420 is 168. If they tell me in the very beginning of the problem that 48% of all the students are male, that means that there's 480 total males. So I can use that to find out how many non-athletic males there are. That would be the difference of the total number of males, which is 480, minus the number of athletic males, which is 168. That's going to give me 312 non-athletic males. If I know that there are a total of 580 non-athletic students and 312 non-athletic males, then 580 minus 312, or 268, would be the number of non-athletic females. The question is asking which of the following is closest to the percent of female students who are not athletes. So we're going to have 268 over 252, the number of athletic females, plus 268, the number of non-athletic females. So 252 plus 268 is going to be 520. So we're going to have 268 over 520. And that's going to be 0.515, which is about 52%, rounding up. So that's going to be answer selection D. And last but not least, number 12. So I started to solve here using the equation method because I solved with the fraction method in the last problem. So here, if I represent each ratio element in terms of x, then I can write the equation 10x plus 12x plus 15x is equal to the total number of flowers in the order, which is 518. 10x plus 12x plus 15x is equal to 37x. Dividing by 37 on both sides, I'm going to find that the common multiple of these ratios is 37. Excuse me, is 14. 518 divided by 37 is 14. The number of orchids is represented by the expression 15x. So that's going to be 15 times the common multiple of 14, meaning that there's 210 orchids in this order. The roses are represented by the expression 10x, so 10 times 14 is 140. 210 orchids minus 140 roses is going to be a difference of 70. So they are actually asking what is the difference between the number of orchids and the number, number of orchids and number of lilies. I misread the question myself. Ooh, let's go ahead and think about this again then. So instead of roses, we want lilies. So what would we change? So instead of 10 over 37, we're going to have 12 over 37. Let me change these here. So that's going to be 12x, so that's 12 times 14, which would be 168. So we're going to have 210 minus 168, which is 42. So my apologies, there was not a typo here. The answer here is C. And if we go over here, lilies, if we evaluated with a fraction, that would be 12 over 37 times the total 518 flowers. So that would also give us a total of 168 lilies. So 210 minus 168 does confirm a difference of 42. So my apologies, I misread my own question. So we were talking about the difference between the number of orchids and the number of lilies. So that would be C42. If you have any questions on anything that we've done today, then please let me know in either the comment section or the live chat feed. If you find these videos helpful, then please like and subscribe. Otherwise, Dr. Tot, do you want to say goodbye to everybody? Come on, you want to get a cookie and say goodbye? We had a good class. Come on. Let's see if he'll do it. Come on. Come on. Let's say goodbye. Can you say bye? Say bye? Come on, bye. Say bye. Come on, bye. Say bye. Very good. There you go. Finally. It's like pulling teeth over here. Thank you guys very much for signing in and watching my video. I hope you have a wonderful night, and I'll talk to you all tomorrow and for the reading stream. And the next math streams where we'll continue with these problems will be Wednesday and Friday sessions. All right. Thank you very much. Have a great night.